The curve fx, x to the power 6 plus x to the power 4 take away 2 has a stationary point at A and FA. Determine the value of A. So if there's a stationary point, what do I know of a stationary point? Well, I know a stationary point is when my derivative equals 0. So if I look at any, now x to the power 6 plus x to the power 4 can look something like that. Stationary points is wherever my gradient equals 0. So there I have stationary points. That is when my gradient equals 0. Okay, so to find that, I first have to find, so for A, to find that, what I'll have to do is I'll have to find my first derivative. My first derivative of fx equals, the 6 goes to the front, it's 6x to the power 5, plus the 4 goes to the front, plus 4x to the power 3. So that's my gradient at any point. For it to be stationary, I'll have to say at stationary point, the derivative of fx equals 0. In other words, 6x to the power 5 plus 4x to the power 3 equals 0. And this is where a lot of you guys have then battled to simplify that. So it was not so much the 11 work, it was more the 10 factorization that you had a problem with. Because for this to be 0, I always look, first of all, I look for highest common factor. And the highest common factor in this case, 6 and 4 is 2, and it's x to the power 3. If I take that out as a common factor, what remains is 3, because 2 times 3 is 6. X, we need 2, because if I multiply exponents, same base, I add exponents, 3 plus 2 is 5, plus 2 goes in 4 twice, x to the power 3 is taken out as a common factor, so this remains. Now my null factor theory says that if I have a product that equals 0, then this equals 0, this equals 0, or this equals 0. Which means that therefore 2x cubed equals 0, or 3x squared plus 2 equals 0. Now for this to be 0, divide by 2, and that means that for anything to be equal to be 0, x must be equal to 0. For this side, I'm going to take plus 2 over to the other side. It becomes 3x squared equals negative 2. I'm going to divide by 3, so x squared equals negative 2 over 3. I have a problem because nothing squared can give me a negative value, or there is numbers, but that is complex numbers. We don't do complex numbers. So x cannot have any real answer. So this is just, we're just going to say this is undefined. This is undefined. So x must equal 0. So my stationary point is where x equals 0. So there's only one. So my graph does not look like that. It looks like this. Okay, so x equals 0. Now I have a. The value of a, therefore, a must equal 0. Let's look at B. Identify the nature of the stationary point using the slope of the tangent. Now this is important. If I say the nature of the stationary point, we can use either gradient table or we can use the second derivative. In this case, it's asked us using the slope of the tangent in the neighborhood. And the neighborhood means in the vicinity of that turning point. So let's say that a is 0, which means x is 0. They ask, how is that a minimum or a maximum? So what I'm going to do is I'm going to say that point there is 0. So let's look at if x is a value to the left, what's the gradient to the left and what's the gradient to the right of that point? And I'm going to, if a is 0, the easiest point is what is the gradient at negative 1. Okay, so if the turning point is at 0, if that is 0, what's the gradient on the left side of it? And I'm going to put that negative 1 back into my first derivative. So I'm going to put it in there, equals 6 minus 1 to the power 5 plus 4 to the power minus 1 cubed. Now if that's an odd number, a negative times a negative odd times is negative, so this is negative 6. Negative 1 to odd power is negative. Negative 1 times is negative 4, so this is negative 10. So if the gradient is negative, then it means it's coming down. The gradient is negative, coming down from left to right. What about on the right hand side of that point? So where the first derivative, where the gradient is at the point 1, where x is 1. It's going to be 6, put it back into this, 6 times 1 to the power 5 plus 4 to the power 1, 1 to the power, that's a lie, big fat one, there's a 3. What I'm going to do is 1 to the power 5 is 1, times 6 is 6, 1 cube is 1, times 4 is 4, so that's positive 10. So if when x is 1, the gradient is positive, which means it go up. So what do they say? From the left hand, when on the left hand side the gradient comes up, then it's 0, and then it's positive, so this will have to be a minimum. If you want, you can check the second derivative rule, but they've asked us to use the slope in the vicinity, and therefore that will be a minimum graph.